First of all, thank you guys for being here. We're very excited to give this talk. Hope you enjoy it. My name is Aladdin, this is Rahul, and we are from O3 team. Before I start, basically, just raise of hand, how many red teamers are here in the room? Cool, so we have almost 10 people here, awesome. So this talk basically is not just for red teamers, so hopefully you guys all enjoy it. So let me first share a few thoughts about red teaming before I start. So when you think about red teaming, you want to basically simulate real-world attacks, right? As a red teamer, your goal is always want to take advantage of that and simulate that specific attack. The attacks, we're talking about attacks that are caused by human adversaries who actually manage and adapt, right, to bypass all your defensives. And you want to, as a red teamer, all the time you want to achieve your objective, right? You want to have a realistic scenario you want to achieve. And so if you work in a software company, you're most likely will be hit by like a backdoor, like software backdoor, right? If you are a hardware company, for example, you'll likely be hit by supply chain attack, etc. When you think about red teaming, you want to perform your attack so with the minimum cost possible, right? Simply because the attacker is not going to take an expensive path if there is like a cheaper one available, right? So traditionally, as security engineers, we viewed the kill chain this way, where the attacker starts by doing reconnaissance, they go all the way to do initial compromise, blah, 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 until they reach actually the goal that they want to achieve. But as an experienced red teamer, this is how actually we see it. You basically have a goal, and that goal is always almost something that is not supposed to happen, right? And because in modern security or modern stacks, you have multi-layer of defense. You've got the blue teamers who are always watching, right? You've got everything behind 2FA. And also you have the production trust boundaries. You have network segregation everywhere. And this is all great, right? This is a typical organization graph, which basically showing a network setup. It has a firewall, restrictions, it has an IDS system. This is very typical, right? It has various systems in corporate environment, restricted path to production. And if an attacker wants to go and reach the high confidential servers, he needs to work a lot, right? He needs to go and find first the low-cost path to reach the target, and also he wants to bypass all these modern technologies or modern defensive technologies. So we're using this setup as an example to show different techniques of how an attacker might actually reach the goal. Obviously, there is lots of ways in which the attacker might reach a goal, but we're going to basically share with you guys a couple of our favorite techniques. The favorite thing for all red teamers, what? Shells, right? So the first thing you're going to do when you start red teaming, get a shell in that organization, right? And you want your shell to be persistent. But you do want the blue team to find you, right? So the reason for that is if you have, this is a typical network, corporate network setup, where you have basically a bunch of endpoints. And you have the attacker who got a backdoor in these laptops via rubber ducky, via like spear phishing, whatever the method is. So the attacker will go and connect to his C2 server, right? But if the blue team is watching, they'll probably find one by doing forensics. But you don't want, if they find one, to find the rest. This case, because we're using the same backdoor everywhere, they'll probably find all your connections. So what is the solution for this problem? This is where we're going to introduce domain fronting, and Rahul is going to talk about that now.
All right, so before I quickly talk about domain fronting, I'll touch upon how a CDN works and what a CDN is. So CDN, aka like Content Delivery Network, is basically a system of distributed servers that's used to serve content to the user, and it's based on geographical locations. So content here means like pages, static files, videos, things like that. So basically, in a nutshell, it speeds up delivery and helps with protection of like surges of traffic to origin servers. It might also help with a small chunk of security, maybe through WAFs or something like that. But honestly, as an attacker, we don't care about all of this. All we care about is this. This might look like a seemingly common set of domain names, but there's one thing that links all of them together. It's that it's all hosted on CloudFront CDN. So let's see, like, think that as an attacker, you could somehow tunnel traffic through these domains. Wouldn't it be nice? So that brings us to this technique called domain fronting, which is essentially tunneling your C2 communications via these high reputation domains. And your traffic would be probably masked because it's tunneled through HTTPS. So in super simple terms, it basically means then that you're swapping in an attacker's host header for HTTP traffic to these high reputation domain names. Like the previous slide, this is how a typical C2 setup looks like. And let's say you bolted on domain fronting on top of it. This is how it would transform. So the main thing you have to keep in mind is that you'll probably have two different domain names. So in the TLS hello SNI field, there'll be your frontable domain, and in your HTTP host header feed will be your redirector, or maybe in this case, your CloudFront distribution. This mismatch is kind of touted as like a feature by all CDN providers, but it's kind of like a bug, I think. I don't know, but it's good to leverage this to our advantage. So all this looks good in theory, but how do you apply this in practice? And this brings us to this malware known as Evil OS X. It's an endpoint rat for OS X. So shout out to the folks who made this. It's pretty neat. We could use this for shelling maybe unlocked boxes on the perimeter. So and this was pretty nice, and you didn't have to recreate some piece of malware from scratch. So essentially what we did was we made a couple of enhancements to it. So the first thing we did was we randomized the launchd label names and also the container names, so it sounds benign. So this is mostly like services which look similar to your default services on Mac OS X. We added full domain fronting to it, so anything from pulling your dropper till the final C2 communication is done via domain fronting. We do have a Git, like a patch ready, so you just download the specific commit of ELOSX, apply this patch, and you're all good to go. Also, from another thing we did was we have a script, so you could set up all your infrastructure with it, like all the underlying infrastructure you need for domain fronting. So it sets up a C2, points a CNAME to the C2, sets up your reverse SL proxy, sets up your Let's Encrypt cert, sets up your CloudFront domain. It does a bunch of good things. So you, as an operator, all you have to do is just run this and you're good to go. We do have a pull request on the way. Like, we still have some cleanups to do, so that'll be soon. This is how it would look like when you bring it all together. So basically, let's say you have an unlocked box on the perimeter. You would use domain fronting to pull your dropper script. Once that's pulled, it would connect to another frontable domain. Also, there's no reason as in why we use two different domain names. We are just trying to be annoying for the blue team. Like, you could just use a single domain name. So let's say it's connected to your frontable domain, then it connects to your, redirects to your CloudFront distribution, which in turn would connect to your actual C2 server. So this way, we have got full domain fronting. And from a blue team perspective, they wouldn't be seeing any direct traffic from your C2 to the victim's box. It'll always be tunneled through CloudFront. And obviously, this should make it pretty hard for them to detect you. So right now, we have a persistent shell, but all the good stuff's usually behind 2FA. And that makes us sad. But there's a way to hijack 2FA. That makes us happy. So the first step here would be like tricking a user into authenticating. So this could be like any way possible, probably through spear phishing or some way. Like, but we thought we'll show you like an interesting vector. So what do you think is wrong with this image? Yeah, so basically there is a misconfiguration and an incoming webhook on this chat application, plus there's a small UI bug, so you could basically impersonate anyone in the channel. So let's say like someone impersonates another person and like the attacker posts a phishing link, someone could click on it and throw in their credentials in. Like basically the point here is you could do some kind of attack and get a person to click on your fake phishing page, just get creative. So now the user visits your fake SO page, they put in their credentials, then probably they'll get redirected to the 2FA page. So now the user would be clicking on a push request. This is where a bunch of interesting things happen. So I'll show this from an animation point of view. So this is where the victim is. They'll probably connect your site. After that, the credentials goes to the C2 server. The C2 server spins up a headless browser. The credentials get passed from the headless browser and it'll log into the SSO site. Now in the SSO site, the headless browser would click on the push request. So within a few seconds, the user would get a push request on his phone. And this is how the code snippet of this looks like. We'll be like publishing this code later on. So now, hopefully, the user will be getting a push request. They'll think it's coming from the real SO. I mean, it's obviously coming from the real SO. They'll approve it. And now the attacker has a valid SO session. And from the user's point of view, they might be slightly annoyed because they'll get redirected to the real SSO page. But I mean, we don't care. We have a valid SSO session and we are all good to go. So right now, our situation looks like this. We have access to the corp environment. We have access to a lot of juicy things like wikis, code repos, emails, ticketing system, and whatever is behind SSO. But we are kind of greedy and we want more, so we decided to do some more things.
So for us to continue this attack where the attacker basically needs to achieve the objective, he needs a couple of things also to finish. So this is where basically we bring up the topic of pipeline pwnage. So how this actually works. Now the attacker needs a path to production. Now the attacker has valid SSO session in corporate environment, but he needs to reach the production. So in the typical CI/CD pipeline, you have the developer who commits code to Git. The code gets built and deployed to artifacts, and those artifacts get deployed to production, right? Basically, everyone knows that Jenkins is great features to give you shells, right? But why you stop there? Jenkins was just one part of the ecosystem that build production code. So what about the packages that get deployed to production, right? Aren't those really great target for the attacker? What about the package dependencies? They give you a straight path to production. What about how this actually works in real life? So this is an example of Cheery module. It's NPM package. It has 6 outgoing dependencies. But if you look at this carefully, there's actually a lot of dependencies here, a huge tree. What if the attacker gets into one of these packages and backdoor them, right, and push them to production? But there's a trick here. Let's see how this actually works. So you have developer 1 and developer 2, and they completely have different pipeline push. So the developer 2 gets the code also built and pushed to Git, and then it gets built and then deployed. If you notice here in this picture, there is 2 different directories on the artifacts that gets deployed. But the point here is it's normal for a higher version package to be pulled to production. Developers don't have necessarily to have access to production. This is where the deployment gets from the production side. This is an example of an npm package.json file, where if you see the character ranges, basically an attacker needs just to push a higher version, and that will get deployed. This is how it actually works. So the attacker push a higher version package with additional code. Let's call it a backdoor. It will override the package with that basically code. It goes to the same process, commit that code, build it, and then push it. Now the attacker backdoor is actually in the artifacts. Once that deployed, all get basically the higher version. Now the attacker has straight path to production where his code is actually running in production. Imagine if you take a common package like that, clone it, and add a reverse shell to it. Isn't this a great idea to get shells everywhere? Probably the attacker will make it less restrictive by adding more checking in the backdoor itself, by checking, for example, the host name, so he can actually target specific servers. Cool, so the attacker now has got access to production, but still he has a few steps to get into the goal. So this is where it comes the unknown for the attacker. The attacker has his code, the backdoor is running in production, but there's lots of ways that that code could be running, and it could be running inside containers, for example, right? Like Docker. Is it a nightmare? Maybe not, actually. There is actually ways to get around that stuff. So one way to basically escape Docker is, so the way Docker works is basically there's a client that communicates with the daemon process using Unix domain socket. Basically, that domain socket runs as root. So any process that can write to that Docker daemon socket also has root access. So if the attacker is able to write to that domain socket, he'll be able to get a privileged access. Let's see actually how this works. So I'll probably show you guys, I don't know if you guys see this, but the attacker will go and basically, so let's see this in a demo. It's easier. See the mouse?
Yeah.
Up.
To the left.
Okay, there's a trick here.
To the left.
All right, so this is how it works. So this is a secret on the host the attacker is interested in reading. And what happened is, this is just to show an example that we're running with Docker sock mounted inside the Docker. And then the attacker basically is inside the container, wants to escape and read that secret on the host. The attacker needs to do something, a trick here, where he needs to run Docker inside Docker, so he can actually do the escape. So the attacker goes ahead and install Docker inside Docker. And then once that's completely installed, the attacker will go ahead and run Docker, mounting the root host into the actual host, and then changing root to the host, and then running bin bash, and then reading the actual secret. And here's the, oh. All right. Expected.
Where's your mom? Command. Right.
All right. So this is.
Having a giant screen doesn't make it any better.
Oh, God.
Right next to it.
All right. So. Okay, so there is another way the attacker could actually escape Docker. If the capability DAC read search is actually inside that Docker container, the attacker might use it. So the Docker before 1.0 allows the DAC read search capability, which basically grants access to a syscall called grant by handle at. This process, or this syscall basically allows your process to read sensitive files or sensitive data from other privileged processes. So let's see how this works. Probably don't want to show the demo again, but this is like a high level how this works actually. So the attacker, again, has interest in reading the secret on the host. And this is just to show that we're actually running this with that read search. And then the attacker, assuming that he's actually inside the container, he'll go ahead and run a couple of commands such as this, and then he will fetch a tool called, or a code called Shocker. It's been known for a while. Use that Shocker to basically utilize this capability to read sensitive files on the host, such as this one. So, I mean, I could show the demo, but
Too scary.
too scared. Okay, so now the attacker has found a way to basically escape Docker containers, right? But there is also, in the modern stack, there is also other stuff, right? Such as Kubernetes. There is Kubernetes deployment almost everywhere now. So if the attacker shall end up inside Kubernetes, what the attacker needs to do to get around that stuff? So one possibility is to escalate privileges using service account token, right? So when if you're familiar with pods in Kubernetes, it's like a bunch of containers. They're actually automatically getting a default service account token. This service account token is used to access the kubelet API. And it usually gives a cluster level access, unless like role-based access control is used. Code execution might be possible if you have, basically if you can read that token inside the container. So the way this works is you've got the attacker. This is an example of we're running just a pod on the Kubernetes. And the attacker verifies that he can actually read the token. And then the attacker will go ahead and fetch kube control inside the pod itself. The attacker will go ahead and run this command, which basically what it'll do, it will create a BusyBox container inside that pod. If you pay attention to the privileged true, and that's basically the trick of, because that service token allows for privileged access, by running this, the attacker will be able to mount stuff inside that BusyBox container and read the actual secret in the host. This is all cool like with demos, right? But we can't do it. The other thing I want to share also with you guys, that the attacker also might not basically find service token privileged, so he can't basically use that attack. So there is another way basically in Kubernetes. By default, the kubelet service listens on TCP/IP port 10250. There is no authentication or authorization on this, and anyone can basically reach that port on the network if it's not restricted and execute commands. So the way this works, it's kind of interesting. So the attacker needs to first find the actual node IP. He can just run nmap inside the container. And then once the attacker finds the actual IP, he will go ahead and list all the pods running. He might be interested in looking at specific secret information inside one of the containers. And the second thing he'll do is he'll go and call that long command curl to get into the actual victim app container. And once the attacker executes that command, it gets a 302 redirection to the domain, to the WebSocket. And that WebSocket, the attacker will basically use the other curl command to read the actual secrets from the other pod, which he's not supposed to read by default. Should I play this demo?
Yeah. Yeah.
I'm gonna risk it, guys. Space doesn't work. All right. So here we assume the attacker basically landed on a compromised app. So the compromised app now, he's interested in reading the victim app data. So he will go ahead and install a couple of things like curl and JQ for parsing the JSON. And then he'll run this command. So he figured out this by just doing nmap, find this port open. He'll run this command. This will basically dump a lot of information about the Kubernetes deployment. But he's actually only interested in listing the actual pods. So he's interested in reaching that victim, if you can see it in the middle, victim app. So he want to read some sensitive information from that app. So he runs this command, give it the victim app, and then run this command called environment variable, which basically is going to list the environment variables. So he gets 302 redirection to this WebSocket. He's going to go ahead and use another curl command to read that socket redirection. Once the attacker runs that, he'll be able to read the actual password and DB password in the top, if you see it. Cool. So the attacker now has more privileged access, right? Now he got into also ways to read information that he's not supposed to read. So what is the next step the attacker is going to do? Well, the next step is basically the attacker is going to collect whatever information he collected, secret password, secret, private keys, whatever, from each host, and then use it to SSH and do some tunneling to the proxy, and then to reach his actual goal. With that, he's kind of now mission accomplished. So this is like a small journey story about how the teamers might basically pivot completely from outside into a very sensitive system inside the organization. So what are the key takeaways? Basically, don't trust completely to your two-factor authentication. You have always to have a multi-layer of defense. You need to have your blue teamers looking at persistent shells. They don't necessarily have to be a simple persistent shell. It could be used with domain fronting, and that makes it interesting. You need basically to trust your build systems, but not completely, because some attacker could actually backdoor any of these packages and have a straight path to production. And finally, the most important thing here to mention is that you've got your Kubernetes deployments, and now it's everywhere. So make sure that it's completely locked down and it's audited, and you're not exposing anything that is not supposed to be exposed. And with that, I would like to thank you guys all for being here. And if you have any questions, please feel free to ask us. No questions?
Oh yeah, all right. One slide back. Oh. Oh yeah.
Yeah, hi.
I like the CloudFront feature. What does CloudFront say about the eventual use of their feature?
They don't say that's an abuse yet.
They know about it?
Probably.
It's well documented.
It's well documented. So.
Part of your coaching with Shocker is Shocker ever going to get fixed? It seems kind of.
So Shocker is fixed with Docker, I think.
1 point.
Yeah, above like 1.0. But if you have this capability enabled on Docker, it's going to work anyways. If you have this capability that read search enabled, even with modern Docker installation, you're going to have this problem.
Okay. That's a few years old at this point, right?
Yeah.
So if that's added, it'll probably work.
Or like a privileged container, basically. Any questions, guys?
Are there any more questions in the audience? If there are no more questions, let's thank our speakers again.